Methylamine is a derivative of ammonia where one hydrogen of ammonia is swapped for a methyl group. It's usually sold as a dissolved gas in various solvents or as pure methylamine in a compressed gas tank. Its main use is as a building block in chemical synthesis to make things like pesticides or pharmaceuticals. Probably one of the most well-known uses for methylamine is in the production of methamphetamine, and just for the record, I'm never going to make that. The methylamine that I'll be producing in this video is the hydrochloride salt, and it's not the freebase amine, which is a gas. The salt is effectively odorless, which is nice, and because it's a solid, it's much easier to work with. I'm honestly not sure how I'm going to use the methylamine that I made in this video because I'm doing this on request and not because I actually needed it for something. I tried to look up some cool things to make, but I couldn't really find anything, so if you guys have any suggestions, please let me know in the comments. For this preparation, we really only need two main chemicals, and that's ammonium chloride and formaldehyde. In total, I used about 250 grams of ammonium chloride and about 500 grams of 37% formaldehyde. One thing to note is that although this reaction does use quite a bit of ammonium chloride, a lot of it is recovered in the end. I followed the ChemPlayer methylamine hydrochloride video and I used it as a guide, and I'm going to provide a link to it in the description. To start things off, I poured in the 250 grams of ammonium chloride to a 3-necked 1-liter round bottom flask. Then, directly on top of the ammonium chloride, I poured in the 500 grams of 37% formaldehyde. On top of this formaldehyde ammonium chloride mixture, I then dropped in a large stir bar. The neck on the right had a bunch of ammonium chloride in it and it wouldn't seal properly, so before moving on, I clean it out with a little bit of paper towel. To the leftmost neck, I add a thermometer and I simply just plug the right one. To the middle neck, I attach a 3-way distillation adapter and then I set up the rest of the distillation apparatus. So this is what our distillation setup looks like, and you should note that every joint has been thoroughly greased because we will need to carry out a vacuum distillation. Once we're ready to get things going, we place a heating mantle below the flask and we turn it on. Initially, there's going to be way too much ammonium chloride to stir anything, and we're going to have to wait till things heat up a little bit and the ammonium chloride starts to dissolve. As we heat things up, a little bit of bubbling might occur, and the solution should slowly clear up as the ammonium chloride dissolves. Once we hit around 60 C, the stir bar was actually able to start stirring things. At around 70 C, it kind of looked the same, but it did seem like the stirring was a little bit better. Once we hit around 80 C, almost all of the ammonium chloride had dissolved, and you can see a lot of bubbling going on. For those of you who are observant, you might notice that the stir bar at the bottom is different, and that's because I actually had to swap it out because the other one really didn't work very well. Once we hit around 85 C, the bubbles that we form are a lot bigger, and it seems like we're producing more. Our goal now is to keep ramping up the temperature until we get it to 104 C, and then we want to keep it there. Things slowly come to a pretty strong boil, and you can see in the receiving flask that we're collecting quite a bit of water. Eventually, our temperature of 104 degrees Celsius is achieved, and we need to adjust the heating mantle to maintain the temperature at 104. This might take a little bit of trial and error, but once the temperature is stabilized, we keep it there for about 3 hours. The overall reaction that we're carrying out is shown here, where we are reacting formaldehyde with ammonium chloride to form our desired methylamine hydrochloride and formic acid as a side product. According to Arrowhead, the first thing that happens is a reaction between the formaldehyde and the ammonium chloride to form methylene imine hydrochloride and water. The methylene imine hydrochloride is then reduced by water to form our desired methylamine hydrochloride, and the formaldehyde is oxidized to produce formic acid. Under the heat of the reaction, though, the formic acid undergoes a decarboxylation and it's converted to CO2 and water. We keep the reaction mixture around 104 C because at this temperature we produce few side products, but we still get a decent reaction rate. Temperature control in this reaction is very important because above 110 C we will start to produce trimethylamine, and if we let it get to around 115 C, we'll actually start to get dimethylamine as our main product instead of methylamine. After we hit the 3-hour mark, there shouldn't be any more water coming over, and we quickly swap out the receiving flask for an empty one. To the vacuum takeoff adapter, we attach our vacuum tubing and we start pulling a vacuum on the apparatus. As we slowly pull a vacuum on the apparatus, it will start to boil again. It's important to pull the vacuum slowly because if we do it all at once, it would pretty easily boil over. When we get the entire apparatus under proper vacuum, we will again start to collect some water. And just like before, we adjust the heating mantle to keep the reaction at a steady 104 degrees Celsius. Now under vacuum, we keep heating the reaction and boiling off water until eventually ammonium chloride crystals start to crash out. When this happens, we turn off the heating mantle and we restore the apparatus to atmospheric pressure. The heating mantle was removed and I let it cool down to around room temperature, and then I cooled it down even further using an ice bath. Here's just a quick comparison on how much was collected before and after the vacuum was applied. After we let it sit in the ice bath for a little while and we precipitate as much of the ammonium chloride as possible, we then need to filter it off. I used my glass fritted filter and I directly filter the liquid into a 500 milliliter flask. It takes a little while, but eventually everything is added to the filter, and then I wash my 1 liter flask a few times with water. When we do these water washings, we want to use a minimal amount of water because we're eventually just going to need to boil it off again. Eventually we'll be done filtering things and we'll be left with a yellow solution containing our desired methylamine hydrochloride, and above it in the filter we'll have a lot of ammonium chloride. A lot of the ammonium chloride in this reaction doesn't react, so what we're collecting here is a portion of what we added in the beginning. This ammonium chloride can be used directly for the production of more methylamine, or it can be recrystallized and used for any other application. The flask is attached to the distillation apparatus, and then we carry out a little more vacuum distillation. At this point, the height of the liquid in the flask is a little bit high and it makes me uncomfortable, so I was very careful at the beginning of the distillation. As the level decreased, I was a little bit more comfortable boiling it harder. Then eventually, just like before, ammonium chloride starts to precipitate out, so we turn off the vacuum, let it cool, and then filter off the ammonium chloride. I use the same filter that I did before without cleaning it, and this time when we filter things off, we get much less ammonium chloride. Just like before, I pull everything through the filter, and I wash the flask a few times with water. When I look at the flask that I'm filtering everything into, it looked a little bit murky and like some ammonium chloride made it through. So to try to fix this, I refiltered everything directly into the round bottom. When I looked at it after filtering it again, it seemed like the solution was a lot clearer and I decided to proceed on. The flask is reattached to the distillation apparatus, and again we try to boil things down. We pull a vacuum on it and heat it, and we keep boiling things down until we get an internal temperature of about 160 C. As we boiled away the water, the temperature slowly started to rise, and it took on an orange color. Eventually, we reached the point where the internal temperature got to about 160 C, and a lot of fuming started to occur. Once this point of 160 C was reached, the heating mantle was removed. Even without the heat, there were a lot of fumes, but once I took the vacuum away, most of them disappeared. We let it cool until it gets to around 150 C, and then we take it off the stand. The contents of the flask are then poured into a beaker, and you can see they immediately start to crystallize. What we have now is our crude methylamine hydrochloride crystals, and we need to wait for them to cool before we can do anything. Methylamine hydrochloride tends to absorb moisture from the air, so while it cools, I covered the top of the beaker with some saran wrap. Anyway, I'm not sure how long it took, but eventually it cooled down to pretty much room temperature, so I took off the saran wrap. I then went ahead and used a total of 200 milliliters of methanol to wash out the flask. The methanol was added sequentially in small portions to make sure that we have a thorough washing. Other procedures call for the use of hot ethanol, but unfortunately, this generally needs to be anhydrous or water-free ethanol, and for most people, it's a lot harder to get this than it is to get methanol. At least for me, the methanol that's sold in stores is nearly anhydrous, and it's also very cheap, so it's hard to rationalize why I would use ethanol instead. Anyway, once it's all added to the beaker, I use a metal spatula to break up the hard cake at the bottom. In theory, our methylamine hydrochloride should be soluble in the methanol, but the ammonium chloride isn't. By washing it with the methanol, we should be able to dissolve all of our methylamine hydrochloride into solution and leave behind ammonium chloride, which can be filtered off. It takes several minutes of mixing, but we really want to make sure that there's no chunks left behind. To make sure that all of the methylamine hydrochloride dissolved, I went ahead and heated the solution. This will make sure that all of our product is in solution, but it will also increase the amount of ammonium chloride contamination that we get. Once we get near the boiling point of the methanol, we can filter things off, and I'll just say here that it's really not smart to do a vacuum filtration. I was a little bit lazy and didn't feel like doing a proper hot filtration, but you'll see here immediately why that's a problem. I pull a vacuum on the solution and it seems to be working okay, but eventually it gets plugged and nothing will pass. If you look at the bottom, you'll see that some of the methanol is boiling away under the vacuum, and this is exactly the problem. Filtering it under vacuum causes a lot of it to evaporate, and since we're at a near saturation point, crystals start to crash out. The jammed filter was pretty easily fixed by just poking it with a small metal rod. The ammonium chloride crystals in the filter were washed twice with about 50 milliliters of warm methanol. When I was done filtering, I looked at my filtrate and I can see that it's cloudy because things have already started to precipitate. Things cooled down quickly and kind of just crashed out, so the crystals that formed aren't very nice, and what we want to do is heat things up again, redissolve everything, and let it cool down slowly so it can form some nice crystals. So it's heated up on a hot plate until everything is dissolved, and then I leave it out to cool down. I left it out overnight, and in the morning we can see that some nice crystals have formed. To fully crystallize everything, I place it in the freezer for a few hours, and you can see that there are a lot more crystals now. To separate our crystals from the methanol, it's very simple. We just break up the crystals, and we filter it off using vacuum filtration. Once everything's been added to the filter and we've pulled a vacuum, I washed it a few times with a little bit of cold methanol. You can see that after just a few washings with the methanol, the crystals seem to have lost their yellow color and they're fairly white. I then go ahead and do one final washing with about 50 milliliters of dichloromethane. This final washing with dichloromethane helps to get rid of any dimethylamine that might have formed in the reaction. After this final washing, I keep the vacuum on for a few minutes just to try to get rid of as much of the solvent as possible. The methylamine hydrochloride is transferred to a piece of paper so that the dichloromethane can evaporate. What's interesting is in the methylamine hydrochloride, you can actually see some weird, different looking crystals, and this is actually ammonium chloride. The crystals that ammonium chloride form are very distinct and different to that of methylamine hydrochloride, and it's very visible when they're present. Just to demonstrate this, on the left we can see what our methylamine hydrochloride crystals look like, and on the right we can see the ammonium chloride. The fact that there's ammonium chloride clumps and crystals present should be a strong indication to you that what we have here isn't super pure. If you recall from just a few minutes ago, we had a bunch of this orange filtrate, and it does contain a little bit of methylamine hydrochloride. If you want to recover it, you can do two things. You can either crash it out with something like acetone, or you can boil it off. I went the lazy route and I just crashed things out. I tried crashing it out with acetone in a 1 liter beaker, but it seemed like we needed a lot more acetone. It does get cloudy, indicating that crystals are falling out, but it still really isn't enough. I transfer everything to my 5 liter beaker, and then I waste a huge amount of acetone to crash everything out. After adding the acetone, I wait a little bit, and when I come back, there's a lot of crystals at the bottom. Most of the liquid is decanted off, and the rest is transferred to a 1 liter beaker and then filtered. I go on to wash it just like before, where I use methanol, followed by a little bit of dichloromethane. You can see this time that when I dump it out on the piece of paper, we don't really have very nice crystals. The stuff that we had before is relatively pure and can be used in synthesis, but this stuff is extremely impure and has to be purified. To get the proper weight and yield of our product, I dried both the crude and the more pure methylamine hydrochloride under vacuum. Drying things under vacuum is pretty simple, and pretty much all you do is add it to a flask, pull a vacuum on it, and leave it for a little bit. In the meantime, I decide to recrystallize all of the ammonium chloride that I recovered. The total recovery was about 160 grams of damp ammonium chloride, and I recrystallized it just using water. Eventually enough water was added so that all the ammonium chloride dissolved, and we're left with a slightly cloudy solution. I'm not sure what the cloudiness is caused by, but I think maybe if you filtered it you can get rid of it, but I couldn't really be bothered. As usual, after everything's dissolved, we let it sit at room temperature and the crystals start to come out. When it's cooled down to about room temperature, I put it in the freezer for a while, and then I filter it off. What we're left with is actually quite pure, fluffy white ammonium chloride. I also dried the ammonium chloride under vacuum, and the final yield is about 50 grams. In the end, we get a final yield of about 50 grams, which corresponds to a percent yield of about 44. In this reaction, we use a large excess of formaldehyde, and we also recover a lot of ammonium chloride, so the yield is based on the amount of ammonium chloride that was actually consumed in the reaction. This is pretty easily calculated by subtracting the amount of ammonium chloride that we recovered from the amount that we started with. According to OrgSyn and some other resources, the typical yield for this reaction is between 40 and 50%, so I'm pretty satisfied with what I got. I measured the melting points of the crude and the more pure methylamine, and you can see here that both are not super pure. The more pure methylamine probably contains a little bit of ammonium chloride, which lowers the melting point, and the crude one probably contains a lot. Before the crude stuff can be used in any synthesis, I think it's pretty much mandatory that it gets recrystallized. Anyway, as I said before, I don't really have a major purpose for the methylamine, and if you guys have any suggestions, please let me know. Please only make suggestions that you think I'll actually do, because I'll never make any illegal drugs, so suggesting that I do it is kind of a waste of time. Anyway, as usual, I'd like to extend a big thanks to all of my supporters on Patreon, and especially those who donate $5 or more. Anyone who donates and supports me on Patreon gets to see my videos 24 hours before I release it to YouTube, and if you donate $5 or more, you get your name at the end of the video like you see here. In the next few months though, I want to work on my Patreon page a lot, and I want to get more rewards going and maybe even get some higher tier ones, and I want to also offer some Patreon exclusive content. Also, as usual, here's the videos that I've currently filmed and the ones I plan to work on. If you have any suggestions or ideas, please feel free to leave them in the comments.